remember.
Okay, objective today is that we now have a new goal. Okay, our new goal is no longer to factor as a blanket statement, but instead to factor completely as a blanket statement. Okay, so it's sort of similar to the idea, if you were to get an answer of 4/8 on a test, would you leave your answer as 4/8? No, why not? Right? We need to turn it into 1/2. Do the instructions tell you to do that? No. We just do it because we know it is an understood thing that we do. Okay, so the same thing is true when we factor. Okay, the statement is factor, but it is an understanding that we will factor completely. Okay, we want to factor as much as we possibly can. Okay, so our objective today is to factor completely. We've already looked at this in smaller pieces, right? We spent a day talking about how do we know if it's a shortcut versus rewriting and factoring by grouping when we're talking about a trinomial. We spent a day talking about, okay, we should look for a GCF first and then count the number of terms. So we've sort of been slowly, we started focused in here and we've sort of slowly been working our way out. So now we can put the entire process together. So every time from this point forward, when you are given something and it asks you to factor it, you are going to start over here on the left side of your flow chart. And the very first thing that you are going to do, so sort of your step one, is going to be to ask yourself if you can factor out a GCF. So we already wrote this out in our notes in words, right? We already wrote out, can you factor out a GCF? If it was a yes, we factored it out. If it was a no, we skipped it. That process is still the same today. So if we see something that says, (4x to the third plus 12x squared minus 16x. Our first thought when we are asked to factor this should not be, oh, I see 3 terms, so I should factor this as a trinomial. Because that should never be our first thought. Our first thought every single time should be, well, is there a GCF?
Yeah.
Okay, so does this have a GCF?
Yes.
Yes. What goes into 4? That will also go into 12. That will also go into 16. 4. Do they all have the variable?
Yes.
Yes, it's x, so we can factor out a 4x. Okay, and this would turn into, let's see, an x squared plus 3x minus 4.
Mm-hmm.
Are we okay there? Okay, our second step is then going to be to count the number of terms, just like that was our second step before, right? This shouldn't feel any different. Now, when we are counting the number of terms, remember, if we have factored out a GCF, we are not counting 1, 2, 3, 4 terms, right? This has already been factored out. So all we are doing is we are looking right here, right? And we would count the number of terms there. It should be the same number of terms that were in the original problem, right? So how many terms does this have?
3.
3. So if it has 3 terms, we then need to make a decision. Is it a trinomial where a does not equal 1? In that case, it's 1 like we had over here in the homework from last night. right? If A does not equal 1, that's where we need to multiply A times C, rewrite it into 4 terms, and then factor by grouping.
But it does equal.
Or, if A does equal 1, we focus on just that piece. Okay, and we can use a shortcut. So A times C, 1 times -4 is -4. Now, this is really frustrating to my students, but just because it's 3 terms does not mean you are going to find a set here. So there will be times that you factor out a GCF. It's 3 terms. You multiply A times C and you can't factor anything else out. I mean, we did that for an entire day at the beginning of the unit, right? Sometimes you can only factor out a GCF. You just have to check and see. Okay, so then we're going to check our signs. Okay, so we need what type of numbers in here if this is a -4?
Negative.
A negative and a positive. And we need the larger sign to be positive. So our smaller one is going to be negative. So do we see a set that works there?
-1.
Right, -1 and 4. So this would factor into an x minus 1 and an x plus 4. We doing okay so far? I mean, if it was one we had to rewrite, we'd have to rewrite and do grouping. Okay, then if we keep scrolling across here, I'm going to leave the work up so because we're still going to use it here. We now have a third step. Okay, our third step is going to be to look for any special cases. And the reason why it says any other, we can't see it up here on the screen, but you see it on your paper, is there's a possibility we already hit special cases if it was 2 terms above that. Okay, so now we need to look at each of these sets of 2 individually and decide, is x minus 1 a special case? Well, it's 2 terms. Is it subtraction?
Yes.
Are they both perfect squares?
No.
No, right? One's a perfect square, but is x a perfect square? No, that would need to be x squared. Right? If it was a special case, we would need to factor it. Okay, then we'll check the other one. Is x plus 4 a special case?
No.
No, because as soon as we see addition, right, we know we can check that off the list. Now, obviously, when we get to this piece that says count the number of terms, there are other situations that we might come across. For example, we might count the number of terms and we might get 2 terms, and we would look for a special case. Right? We might count the number of terms and we might get 4 terms, and we would factor by grouping. Does that make sense? Okay, so flip your flowchart either onto the back, or you could also write this if you have space somewhere on the front and you just want to put it there. That's fine. Nope, that should be a 32. This should be a 32, sorry. 2x to the 4th minus 32. Okay, so we're going to start at the very beginning of our flowchart. Step 1 says to look for a GCF. Okay, so if we look at 2x to the 4th minus 32, do we see a GCF?
2.
Yes, a GCF of 2, right? So we can factor that out.
You get x 4 and minus 6.
So how many terms does this have? 2, right? Because the only terms that we are focusing on is right here. So what should we look for if we count and we get 2 terms?
Special case.
A special case.
And
Is x to the 4th minus 16 a special case?
yes.
Yes. Okay, so what times itself gives us 16?
4.
4. What do we do with the exponent? Half of it, right? So x squared and 4. So we said this would then turn into 1 with an addition sign. And 1 with a subtraction sign. Okay, so that's step 2.
Look for any other. There's 2 or
Yeah,
one
you said
there.
not, there should.
Yeah. So step 3 says to look for any other special cases. So now we're going to look at these individually. Is x squared plus 4 a special case? No, because it's an addition sign. Is x squared minus 4 a special case?
Yes.
Yes, because it's 2 terms, it's subtraction, and they are both perfect squares. So what number times itself gives us 4?
2.
2. What number times itself gives us x squared?
That's
So we'll get an x plus 2 and an x minus 2. Now remember, we were associating this with the idea of prime factoring, right? Where we would take this and it's split into this and this. The x to the 4th minus 16 split into this and this. And then the x squared minus 4 split here and here. And so our final answer included anything that didn't have a branch coming off of it. Right? So our final answer is the same idea. It's still including anything that does not have a branch coming off of it. So the 2 is part of the answer. The x squared plus 4 is part of the answer.
and the x plus 2.
And the x plus 2 and the x minus 2 are part of the answer. And that would be 2x to the 4th minus 32 factored completely. And then students are like, why in the world would you want to write it that way when this is way easier? It'll make sense later in the trimester. Okay, sometimes it benefits us to have it factored. Are we okay on that one? Any questions there?
Wait, can you,
Yes, I sure can.
what numbers did you, or what, you said you picked ones that don't have a branch coming up?
Right, the ones that I didn't split. So once I split this here and here, I never did anything else with the 2.
Yeah.
So the 2 is part of the answer. Right, once I did this, I never did anything else with the x squared plus 4. So that's part of the answer. I did something with this, so it's not part of the answer. Okay, so I promise what I'm about to write down is short. For those of you who are trying to write.
X squared minus 8. You can use the shortcut.
Okay, but that's never what we want to think first. What is always our first thought?
GCF.
Is there a GCF?
No.
Does this have a GCF? No. So we skip step 1. Okay, so then we count the number of terms. How many terms is this?
3.
3. So we're going to decide if we can factor this as a trinomial. Okay, so A times C, 1 times 19 is 19. Yes, Olivia?
So, if we see that there's a shortcut, do we have to do everything else and then go to the shortcut?
You should always check for a GCF first.
Well, I know, but like, when we go into a trinomial and we see that there is a shortcut, you know how you can factor it out normally?
Right, you would not need to consider rewriting this by grouping at all. You can just go right onto a shortcut.
Okay.
Right, so that, I get what you're saying. That is not a do the top and then do the bottom. That's pick which situation you're in.
Okay.
Okay, so we have 1 and 19. And that's it.
Yeah.
2 and nothing, 3 and nothing, 4 and nothing, 5 and nothing, 6 and nothing, 7 and nothing. So can we factor this as a trinomial? Nope. So then we move on to the next step. Look for any special cases. Any special cases? But no, because there's no two terms. So can we do anything with this? No. Okay, so this is what we call prime. What is a prime number?
Number that only.
A number that only has multiples of 1 in itself. Well, this only has multiples of 1 in itself. It's not a special case. It's not a trinomial that we can factor. It's not 4 terms, so we can't do grouping. There's no GCF. We can't factor this into anything, so we say this is prime. Now, it terrifies me when I start teaching my students this, because we are now done with information. So how much did I talk about prime? For like 30 seconds. So when you take your test next week, how many problems on the test do you think are going to be prime? Yeah, not very many. And my students are like, ooh, prime, 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 prime. I love the word prime. I can't find something that works, so I'm going to write prime. And I'm like, -4, -4, -4, -4. Because there is nothing there for me to grade. Do not fall in love with this word. We are working on factoring. I'm not going to give you a bunch of problems that are prime. Got it?
Please do. That'd make our test so much